Hi, welcome back to our discussion on Jacobian substitution for multivariable. We're going to continue our discussion, but before we do that, we're looking for a volume. So let's say we want to find the volume of this function, and we're given this r. Remember, this is the area of my base, and we're going to multiply that by our height here to get our volume. So today we're going to take a look at, again, what happens if r is not very easy to work with. Our region is not very nice. And the example we have here, for example number 1, is we have this ellipse. We have this ellipse, x squared over 4 plus y squared over 36 is 1. Now if I were to sketch this, I know that my domain is 2, -2, 6, and -6. There's my ellipse. If we draw a vertical rectangle down here to find the area, I can say that my change in x and y, so my change in y for my limits, now if I solve it, this would just be like y equals the square root of 36 minus 9x squared. Right there, if we solve that, okay? So my change in y is going to go from the negative of that, square root of 36 minus 9x squared, to the positive square root of 36 minus 9y squared. Already not very nice. Where my x is not so bad, -2 to +2. And this is just ugly to work with. So we don't really like that. So let's talk about the substitutions. Now here they tell us x is 2u and y is 6v. Now they're picking these on purpose to make this into a circle. It takes practice, but some of you guys, all of you guys should eventually be able to kind of pick out your own x and y. Remember, we want to substitute in. We want to substitute u and v into, or better yet, for x's and y's. And that's going to make it easier, hopefully to make it an easier base for us. And they tell us what to use here. So let's see, the first one they say x is 2u. So I can just write this as 2u squared over 4 plus y is 6v squared over 36 equal to 1. And of course, if I simplify this, this becomes u squared plus v squared equals 1. And this is a circle. And circles are so much easier to work with. Let's look at the circle here. We know it has a radius of 1. Right there. So let's find the domain for that circle real quick. So if I draw my vertical line going down here, I know that my circle has the equation. Remember, it's going to be v, because remember this time we are u and v for x and y. So v is the square root of 1 minus u squared. So my limits here are going to be, my change in u's are going to be from the negative square root of 1 minus u squared to the positive square root of 1 minus u squared. And v, whoops, I keep doing that. That's going to be v. And our u is going to go from -1 to +1. Now, but what's really nice about circles is the fact that we can use polar graphs. And in a polar graph, ready? There's my line, there's r, there's theta. So I know that r goes from 0 to 1, and theta goes from 0 to 2 pi. Whoa! Look at that! That is so much easier to work with. This is very much easier to integrate than this one. Now we will have some other conversions to do, but we'll talk about those conversions later, because it's all about that base. Alright, so let's take a look at another example. Here we're given the following parallelogram, and we want to determine the region we would get by applying the following transformations. So let's go ahead and see what our base is. So let's draw the base out. It's that parallelogram. First one's at 1, 0, 4, 3, 1 up 6, not drawing the scale here, and -2, 3. And we got this parallelogram. So there's our base region. Now we want to be able to find the limits. But to get the limits, we need the equations of the line. Now, I know at this point you all know how to find the equations of all these lines, so I'm just going to go ahead and give those to you. this line right here would be y equals negative x plus 7. Over here, y equals x plus 5. Over here, y equals x minus 1. And over here, y equals negative x plus 1. Now, if I wanted to integrate right now, I can do this, but I'd have to have two domains, two regions, or two sets of limits here. My first one, the first one here, if I draw vertical here, it's going to go, my change in y is going to go from negative x plus 1 all the way to x plus 5, where the x's here go from negative 2 to 1. My second one, my y's over here, will go from x minus 1 to the top negative x plus 7, and those x's are going to go from 1 to 4. Now, it's not hard to set up, but remember, we're going to be using this later on to get volumes, and these might be a little harder to integrate. So what we can use is that Jacobian substitution. I can use these values right here that change x and y into u's and v's to make this maybe an easier domain to work with. So let's go ahead and do that. So let's go ahead and use substitution to get the new base. So I have to convert each one of these. The first one we'll start off with is x plus 5. Y equals x plus 5. So they're telling me x is, or y is equal to this 1/2 v plus u. And I'm going to go and distribute 1/2 v plus 1/2 u equals x, which is 1/2 v minus 1/2 u plus 5. V's cancel. And if we bring over the u, we're going to get u equals 5. And of course, we know that that's going to be a vertical line when we plug it in because we'll be terms of u and v. My next one, let's do y equals negative x plus 7. All right, substitute in y, 1/2 v plus 1/2 u minus, equals, negative 1/2 v, be careful, plus 1/2 u, plus 7, right out of room. So again, here the u's cancel, and we get v equals 7. That's going to be our horizontal line. Our next one, y equals x minus 1. Plugging it in, we get 1/2 v plus 1/2 u equals, plug it in for our x, we get 1/2 v minus 1/2 u minus 1. V's cancel, u is negative 1. And the last one, where is it? Y equals negative x plus 1. I just plug it in again. Whoops, sorry. 1/2 v plus 1/2 u equals negative 1/2 v, be careful signs, plus 1/2 u plus 1. U's cancel, and we get v equals 1. Notice, we're just dealing with horizontal and vertical lines now. We got rid of those slants. So when I graph this, in terms of u and v, u is 5, there's my vertical line, v 7, that's horizontal line, u is negative 1, right here, and v is 1, right here. So now, my whole region is here. And I can write my new limits. Remember, this is negative 1, that was 7 right there. So if I draw my vertical line right now, to get my new limits, excuse me, my change in v is going to go from negative 1 to 7. My change in u will go from, v goes from positive 1. My x value goes from negative 1 to positive 5. Sorry, that was at negative 1 up here. Positive 1 up here, so. And there's our new limit. Notice, much easier to use right there. All right, come back to part 3. We'll take a look at some more examples. I'll see you then.